Life had spent hundreds of millions of years exploring the boundaries of what was possible. It had learned to sense light, to respond to danger, to move, to hunt, and to think in the smallest, simplest ways. But all these achievements, magnificent as they were, still belonged to organisms that lived their entire existence as single, isolated units. Life had not yet learned its greatest skill, the ability to collaborate, to build something larger than itself, something that could not be achieved by a lone cell drifting through the ancient seas. The next chapter in Earth's story would ignite one of the greatest transformations the planet would ever witness. It would not arrive with sound or violence, but with quiet cooperation, an alliance so fundamental that it would reshape every organism that came after. This was the rise of complex multicellular life, and it began in places few would have noticed: dim tidal pools, nutrient-rich shallows, and deep, oxygen-heavy regions of the ocean where chemistry danced in perfect harmony. For most of Earth's early history, single cells were solitary survivors. They competed fiercely for resources, battling the currents, consuming sunlight or chemical energy, and reproducing endlessly. But some cells discovered that survival became easier when they remained together after dividing. Instead of drifting apart, they stayed attached like sisters holding hands in the endless ocean. At first, this grouping brought simple benefits: shared nutrients, protection from predators, more efficient movement. But something unexpected happened. These clusters began to specialize. One cell might take in nutrients, another might help with movement, another might sense changes in the environment. Slowly, the idea of division of labor emerged not from intention but from survival. The ocean rewarded cooperation, and evolution listened. This cooperation deepened when one of the most extraordinary events in biological history occurred: endosymbiosis, the merging of life forms into a single, unified being. A large ancient cell swallowed a smaller, energy-producing bacterium. But instead of digesting it, the host cell discovered that the little organism inside could produce enormous amounts of energy. In return, the smaller cell found protection and nutrients. It was a pact that would last forever. Over time, the internal bacterium became an inseparable part of its host. It transformed into what we now know as the mitochondrion, the powerhouse of all complex life. This was no mere adaptation, it was a revolution. With this new internal energy source, cells could grow larger, store more information, and build more intricate structures. They could afford to take risks, to evolve new shapes, to explore levels of organization that had never before been possible, but complexity was a dangerous game. Multicellular organisms needed to ensure that each cell obeyed the whole, that no single cell tried to replicate endlessly or wander off in rebellion. The earliest multicellular beings developed chemical signals to communicate with billions of their own cells. They developed systems to regulate growth, repair damage, and even instruct old or malfunctioning cells to self-destruct for the greater good. Through these mechanisms, another miracle emerged: biological identity. The idea that many cells could act as one unified creature. With time, these organisms grew more sophisticated. Sheets of cells folded into tubes, forming the earliest digestive systems. Networks of cells shaped into filaments became primitive muscles, allowing the organism to move not as drifting particles but as a coordinated body. Sensory cells clustered into primitive patches capable of detecting changes in light or pressure. The foundations of tissues, organs, and body plans appeared like architectural sketches waiting for the future. The environment, too, was changing. Oxygen levels continued to rise, enriching the oceans and pushing life toward greater metabolic potential. With every passing million years, Earth grew more vibrant, more capable of supporting complexity. And in this growing richness, life expanded its creativity. Some early multicellular beings formed delicate fronds anchored to the seafloor, gently waving like underwater forests. Others shaped into soft-bodied forms drifting across the currents, living worlds made of thousands of cells working in harmony. These organisms were fragile, often small, and rarely preserved in fossils, but they laid the groundwork for the dramatic explosion of diversity yet to come. One of the most profound innovations to arise during this era was developmental programming, the process by which a single fertilized cell could grow, differentiate, and become a full organism with specialized structures. It was nature's greatest blueprint, a symphony of genetic instructions that told cells where to go, what to become, and when to activate their roles. Every creature that would ever walk, swim, or fly on Earth depended on this elegant choreography, yet the path to complexity was not a straight line. Many organisms failed, trapped in evolutionary dead ends. Some were too large to sustain themselves, others too fragile to survive predators. Some developed complex bodies but lacked the ability to reproduce reliably. Evolution experimented relentlessly, and each failure taught life valuable lessons. Still, the movement toward complexity was unstoppable. By now, the oceans were filled with shimmering clouds of plankton, colonies of coordinated cells, and early forms of soft-bodied creatures. Though they lacked bones, shells, or limbs, their impact on Earth was profound. They were rewriting the rules of survival, inventing the first ecosystems built on interaction rather than isolation. But Earth had another test waiting. The rise of multicellular life was only the beginning. Ahead lay a period of chaos, innovation, and unimaginable change, a moment when life would burst into forms so diverse, so strange, and so magnificent that the world would be transformed forever. This moment would later be known as the Cambrian explosion, and it would change everything. The story continues. Within this chaotic explosion of new life, certain creatures rose to dominance. Among them were the arthropods, ancestors of insects, spiders, and crustaceans. They possessed jointed limbs, segmented bodies, and protective exoskeletons that allowed them to explore environments others could not. Their versatility would make them one of the most successful groups in Earth's history. Another early marvel was Anomalocaris, one of the first true apex predators. With large compound eyes, powerful grasping limbs, and a flexible, undulating body, it patrolled the Cambrian seas as a symbol of nature's new capacity for complexity. It hunted trilobites and other armored creatures, asserting dominance in a world where survival demanded speed and innovation. Trilobites themselves became icons of the era, small, hard-shelled explorers that scuttled across the seafloor, their many legs moving with rhythmic precision. Their eyes were among the earliest made of calcite, the same mineral found in rocks, granting them vision sharper than anything else alive. They left behind thousands of species and millions of fossils, silent witnesses to the vast diversity of this ancient world. Yet the Cambrian awakening was not just a story of predators and prey. It was a story of possibility. For the first time, creatures shaped their surroundings in meaningful ways. Burrowers oxygenated the seafloor. Grazers scraped mats of algae, controlling ecosystems. Swimmers stirred the waters, spreading nutrients and influencing global chemistry. Life was no longer merely adapting, it was transforming the planet itself. One of the most transformative innovations was the emergence of vision. Until this moment, sensing had been simple, detecting chemicals, pressure, or faint glimmers of light. But now, evolution crafted the first complex eyes, structures capable of forming images, recognizing shapes, and detecting motion with startling precision. Once organisms could see, everything changed. Predators became more effective, prey became more evasive. Colors, patterns, and camouflage blossomed. The oceans filled with creatures reacting to one another with unprecedented speed and intention. Alongside vision came the development of segmented bodies, flexible architectures that allowed creatures to bend, twist, and coordinate their movements with remarkable agility. These segmented designs formed the basis for many future organisms, worms, insects, crustaceans, and countless others. Joints emerged soon after, leading to limbs built not just for swimming but for crawling, grasping, and manipulating the world. The Cambrian seas also saw the rise of armor. For the first time, creatures constructing mineral shells and protective exoskeletons became common. These defenses provided safety but also changed entire ecosystems. Predators evolved powerful claws and appendages to pierce or pry open these new fortresses. The arms race of attack and defense had begun, driving evolution forward with relentless energy. But the greatest innovation of all was internal, the rapid sophistication of nervous systems. The simple nerve nets of earlier animals were no longer enough. Creatures needed to coordinate legs, respond to predators, process visual information, and navigate complex environments. Evolution responded by building dense clusters of neurons, primitive brains capable of learning, reacting, and controlling increasingly complex bodies. Intelligence was no longer an accident, it was becoming a tool. For billions of years, Earth had been a quiet world of simple forms. Life existed, persistent, resilient, endlessly creative, but understated. The oceans were filled with drifting colonies, soft-bodied organisms, and gentle creatures that left little behind except whispers in ancient sediments. But then, in a span of geological time so brief it was like lightning striking the planet's history, everything changed. The story of life accelerated with a force so dramatic, so explosive, that the world would never be the same again. This was the Cambrian awakening, an evolutionary revolution that reshaped the entire fabric of biology. In mere tens of millions of years, a blink compared to the billions before, life invented nearly every major body plan that would ever exist. Legs, eyes, claws, shells, spines, jaws, segments, brains, everything that defines the diversity of the modern world sprang into being with astonishing speed. It was as if the planet had suddenly unlocked new rules, and life seized them with wild enthusiasm. The seas of the Cambrian period were nothing like the calm, drifting oceans of earlier ages. They were arenas of innovation, laboratories of biological experimentation, ecosystems bursting with movement and intention. Creatures no longer simply floated, they crawled, dug, hunted, hid, and chased. The world had become competitive in a way it had never been before. And with competition came invention. But what triggered this explosion of creativity? Scientists have proposed many ideas, and perhaps all played a role. Rising oxygen levels granted more energy for complex bodies. New genetic tools, like the Hox genes that guided body development, unlocked nearly limitless designs. Environmental changes opened vast new ecological spaces. And once life crossed a certain threshold of complexity, competition and interaction accelerated evolution at unprecedented speed. Whatever the cause, the outcome was unmistakable. Earth had become a world of fierce, diverse, dynamic creatures. The quiet age of simplicity was gone forever. Complexity had arrived, and with it came the foundation for everything that would follow: the rise of fish. Plants, insects, reptiles, mammals, and eventually, minds capable of asking questions about their origins. But the Cambrian was only the beginning. Ahead lay continents shifting, ecosystems rising and collapsing, oceans retreating and returning. Life would face extinction and rebirth, catastrophe and opportunity. And each upheaval would shape the path toward the distant future. The story of life on Earth was entering a new era, one of triumphs, tragedies, and relentless transformation. The journey continues. With plants and arthropods shaping the land, the stage was set for one of the most significant transitions in the history of life: the rise of vertebrates onto land. The ancestors of this great migration were fish living in shallow, oxygen-poor waters. Many of these fish evolved primitive lungs to supplement their gills, allowing them to gulp air when water oxygen levels dropped. Their fins grew more robust, supported by strong bones that could push against the seafloor. Among them were the lobe-finned fish, remarkable creatures with thick, muscular fins capable of bearing weight. In their bodies lay the blueprint for future limbs. They did not yet walk, but they could heave themselves across mudflats, navigating between shrinking pools during droughts. Natural selection favored individuals capable of moving farther, breathing longer, surviving on land for brief but crucial moments. Over millions of years, these traits accumulated. Then, in a moment etched permanently into evolutionary history, the first true tetrapods emerged. They were neither fully fish nor fully land animals but something in between. Their fins had transformed into limbs with bones recognizable in every modern human: humerus, radius, ulna, femur, tibia, fibula. Their skulls strengthened to support breathing air. Their senses adapted to a world where light behaved differently, where sound traveled through air instead of water. These early tetrapods crawled onto land not for conquest, but for survival, seeking food, safety, or new habitats. Yet their presence marked the beginning of a new chapter for Earth itself. Land was no longer silent or empty. It began to echo with movement, with the faint shuffling of limbs dragging bodies across damp soil, with the soft rustle of early plants spreading across the terrain. The continents, once barren, were awakening. These pioneers became the earliest land plants, ancestors of mosses and liverworts. They formed low, spongy mats along shorelines, breaking the ancient silence of Earth's barren continents. With them came something extraordinary: the ability to alter the environment. Their photosynthetic activity pumped oxygen into the atmosphere. Their presence trapped moisture and stabilized soil. They softened harsh rock into nutrient-rich sediment. In time, they created microhabitats that invited other forms of life to follow: but plants alone could not reshape continents. They needed support, animals capable of grazing, decomposing, and forming the foundations of land-based ecosystems. And so evolution set its sights on a new challenge, bringing animals onto land. The first pioneers of this transition were arthropods, descendants of Cambrian creatures whose jointed limbs and protective exoskeletons gave them a formidable advantage. Some early arthropods began venturing into tidal zones to feed on the algae mats forming along the coast. Their bodies already contained systems, primitive lungs or gill-like structures, that allowed them to tolerate short exposures to air. With time, these structures evolved. Some arthropods developed book lungs, others tracheal tubes that channeled air directly into their bodies. Their limbs strengthened to support their weight outside the buoyancy of water. Slowly, methodically, they crept farther from the waves. The first true land animals were simple, millipede-like creatures feeding on decaying plant matter, followed by predatory ancestors of modern spiders and scorpions. These early terrestrial ecosystems were small, quiet, and fragile. But they were the beginning of something monumental, a world where life no longer depended on the sea. For hundreds of millions of years, life had belonged entirely to the oceans. Every creature that evolved, every experiment nature attempted, every triumph and failure unfolded beneath waves of salt water. The sea had been a sanctuary, stable, protective, rich with nutrients. But Earth itself had always been larger than the oceans. Beyond the tides and reefs and deep trenches lay an untouched world, the vast expanse of land, silent and barren, shaped only by wind, erosion, and the relentless forces of geology. For ages, this land was lifeless. Waves crashed against empty shores. Rain fell on naked rock. Rivers carved their paths through landscapes devoid of even the simplest plant. Nothing breathed the air. Nothing moved across the continents. And yet, something profound was beginning to stir in the waters that kissed the edges of these desolate coasts. The Cambrian explosion had given rise to unprecedented diversity, and evolutionary momentum carried that creativity forward into the Ordovician and Silurian periods. Algae, the earliest architects of photosynthesis, began to colonize shallow waters near the shore. These microscopic pioneers formed slippery green films on rocks, thriving wherever sunlight reached. They were not yet true land dwellers, but they were the first to test the boundary between sea and earth. Over countless generations, some algae developed structures that allowed them to cling tightly to surfaces exposed during low tide. As waves receded, these organisms endured brief moments of exposure to open air. Each moment was a lesson. Evolution worked quietly, strengthening cell walls, adjusting pigments, refining their ability to prevent desiccation. Bit by bit, they gained resilience. And then, in one of life's most transformative leaps, some of these algae evolved the capacity to survive not just moments above the water, but hours, then days. Forests of simple plants expanded inland. Soils thickened. Rivers became corridors of life. Swamps formed, rich with nutrients. The world was growing greener, more vibrant, more interconnected. And the creatures that ventured onto land adapted with astonishing speed, but evolution was never a gentle guide. Land was harsh, its temperatures severe, its air dry, its predators relentless. For every species that succeeded, countless others failed. And as life conquered the continents, Earth was preparing yet another dramatic shift, one that would bring both flourishing diversity and devastating catastrophe. The age of land was just beginning, and with it came new challenges and new wonders. In the swampy lowlands, coal forests grew so dense that sunlight barely penetrated their canopies. The decomposition of vast amounts of plant matter slowed, building thick layers of organic material that would eventually become the coal deposits of the modern world. These forests were the factories of Earth's oxygen-rich atmosphere, and the creatures that lived within them flourished. Among the most successful were the early reptiles. Some remained small insect eaters, darting across the forest floor with the agility of modern lizards. Others evolved larger bodies, powerful jaws, and strong limbs. Some took to climbing trees, others hunted in swamps. The diversity of forms exploded, hinting at the future domination of land vertebrates, yet with every rise came instability. The Earth was preparing to test life once again. Volcanic activity intensified as continents continued their collision course. Climate patterns shifted unpredictably. Some regions grew colder, others became unbearably arid. The forests that once blanketed the continents began to wither. Oxygen levels dropped. Massive wildfires swept across the land, ignited by lightning and fueled by the planet's still oxygen-rich air. The stability that had nurtured the age of giants was crumbling. Amid these changes, new evolutionary pressures shaped the animals that remained. Some reptiles evolved more efficient metabolisms or developed stronger legs to roam new, harsher landscapes. Others were driven to extinction, unable to adapt to the rapid shifts in climate and habitat. The mighty arthropods shrank as oxygen levels fell, losing their dominance to reptiles better suited to the changing world. Life was entering a period of transition, one that would test the resilience of every species and reorder the balance of ecosystems across the planet. Yet nature never stopped experimenting. Deep within marshy waters lived fish that possessed both gills and primitive lungs, creatures that could brave the surface when necessary. Some evolved sturdy ribs and stronger limbs, allowing them to move farther from water. Their skulls thickened, their senses sharpened. Their bodies were preparing for a transformation that would change the path of all future life. The great forests of the late Paleozoic era saw the birth of one of evolution's most ingenious inventions, the amniotic egg. This remarkable structure freed life from its dependence on water for reproduction. Encased in protective shells or leathery coverings, amniotic eggs held within them a self-contained aquatic world. Embryos could now develop on dry land, safe from predators lurking in the shallows. With this innovation, a new class of animals emerged, creatures capable of fully embracing the terrestrial world. These were the early reptiles, ancestors of lineages that would one day dominate earth and sky. Their skin was tough and resistant to drying out. Their lungs were efficient, built for life in open air. And their eggs allowed them to colonize environments that amphibians could never reach. Meanwhile, Earth itself was shifting. The continents were slowly drifting toward each other, pushed by forces deep within the planet. Mountain ranges rose. Volcanoes erupted. Rivers carved new paths. The formation of massive supercontinents altered weather patterns, drying some regions while flooding others. Forests expanded and contracted in response, and life evolved with them. The spread of life onto land reshaped Earth in ways no earlier transformation had. The oceans had always been rich, dynamic, full of movement and competition, but now the continents themselves were awakening. What began as thin carpets of moss-like plants soon grew into lush expanses of green. Over tens of millions of years, plants evolved stems, vascular systems, and roots that allowed them to grow taller, thicker, and stronger. They reached for sunlight with a determination that would eventually build the first great forests in Earth's history. As these early forests expanded, they created ecosystems unlike anything the world had ever known. Once barren landscapes filled with humidity, shade, nutrients, and habitats. Rivers snaked through dense green canopies, swamps grew deep with decaying plant matter, and the air itself changed. Plants pumped enormous amounts of oxygen into the atmosphere, pushing levels far higher than anything seen before. The world became more fire-prone, more breathable, and far more alive. These forests gave rise to creatures that thrived in their dark and tangled environments. Arthropods, emboldened by the abundance of oxygen, grew to staggering sizes. Millipedes longer than humans crawled across the leaf-covered ground. Giant scorpions hunted in the shadows, their bodies glistening in the humid air. Dragonflies with wingspans as wide as eagles soared above the canopy. Their flight made effortless by the rich atmosphere, but the true revolution of this age was unfolding quietly beneath roots and within muddy swamps. Vertebrates, descendants of the first tetrapods, continued to evolve, adapting to a world where land offered both opportunity and peril. Early amphibians, with their slick skins and fragile eggs, lived dual lives between water and earth. They grew larger, more diverse, but remained tied to the wetlands that protected their delicate young. Their existence was a compromise, a halfway step between two worlds. The forests would burn. The swamps would dry. The giants would fall. But from the ashes of this changing world, new forms would rise, forging the path toward the age of reptiles, the age of dinosaurs, and the long march toward the modern world. The story continues. Dr. Hale stood beside the console, expression tense. He'd barely slept either. "You're early," he said quietly. "So are you," I replied. He offered a weak smile, then turned back to the data. "Last night's readings confirm it again. The resonance frequency is still synced with your neurological pattern." I nodded, though the confirmation did nothing to steady my nerves. "Are you sure you want to proceed?" Hale asked, voice dropping to a whisper. This wasn't the question of a scientist. This was the question of a friend. "No," I said honestly. "But I know I have to." Hale swallowed. "We can delay it. Search for another solution." "You don't have to do this, Al, there is no time." I interrupted. "And you know it." Outside the containment window, the energy inside the core pulsed, as if sensing the tension in the room. The station's sensors had only grown more unstable. The void was closing in. If we didn't act now, the collapse would spread across multiple research bases, and potentially far beyond. Hale looked down, shoulders sagging. "We'll monitor everything from here. If anything goes wrong, then follow the contingency plan," I finished. The silence between us was heavy, full of unspoken emotions neither of us had the strength to articulate. Finally, I stepped toward the isolation chamber. My fingers hovered over the biometric panel for a heartbeat longer than they should have, but I pressed down. The door slid open, releasing a gust of cold, sterile air. I felt the faint vibration of the energy through the floor, like distant thunder calling me forward. I woke before the lights of the station cycled into morning mode, long before the artificial glow could imitate the sun. For a moment, I simply lay there, listening to the hum of the life support systems, the sound that had become the heartbeat of this strange steel world. It was steady, rhythmic, almost calm. Nothing in that sound hinted at the storm building beneath the surface of my thoughts. Today was the day. The day everything might end, or begin. I rose slowly, as though any abrupt movement might shatter the fragile certainty I had forced myself to accept. The incident with the particle surge had changed more than just the station's structural integrity. It had changed the path of my life. Twisted it into a direction I had never prepared for. I wasn't just an observer of the void anymore. I was connected to it. And that truth weighed on me like an invisible hand pressing firmly against my chest. As I dressed, the memories of the last few weeks replayed like a slow-motion sequence. The flickering lights. The trembling metal beneath my feet. The impossible patterns in the quantum readings that aligned perfectly with my own biofeedback. I had tried to resist the idea, God knows I had, but the deeper I looked, the clearer it became. The void wasn't only reacting to the station. It was reacting to me. When the doors slid open, the corridor outside was silent, illuminated by the sterile white glow that never changed. Never aged, never softened. I walked toward the research wing, each step echoing like a countdown. The doors recognized my ID and opened without a sound, revealing the centerpiece of all our discoveries, the core. The swirling mass of energy filled the containment chamber like a floating galaxy, its tendrils rippling with silent motion. It wasn't violent. It wasn't peaceful. It simply was, a presence beyond comprehension. As the truth unfolded, the swirling stars dimmed, replaced by a calm darkness. Not frightening. Not empty. Peaceful. Purposeful. A voice resonated, not with sound, but with meaning. You are not losing yourself. You are finding us. I inhaled sharply, us, before I could form the question. Light surged again, rushing toward me like a river of pure revelation, then everything snapped back, the chamber reappeared, the core stabilized, my knees gave way as I collapsed onto the platform, gasping for air as the physical world crashed down on me. The doors hissed open instantly, and Hale rushed inside. Jean. Jean, can you hear me? I lifted my head slowly, and I smiled. Because I understood, I know what the void is, I whispered. And I know what we have to do next. Hale froze, shock etched across his face. What do you mean? I looked past him, through the glass, at the swirling core. It no longer felt alien. It felt connected. Like part of me was still inside it, still listening, still learning. This isn't the end, I said, voice steadying. It's the beginning of everything. Hale stared at me, breath caught in his throat, and I realized, part 15 was not a conclusion, it was a threshold, a door opening into something larger, stranger, and far more beautiful than anything we had dared imagine. Inside the chamber, the noise cut away completely. It was as if the world itself was holding its breath. I positioned myself at the center platform, facing the swirling mass. My heart beat hard against my ribs. My hands trembled. But my steps remained steady. The platform lights activated, forming a humming circle around me, my last physical anchor before the shift. From the control booth, Hale's voice crackled through the intercom. Initializing neural interface in 5, 4, 3. The chamber darkened. Point 2, 1. The core flared, and suddenly, everything went white, not bright, white, a blankness so absolute it felt like the absence of existence. A moment later, colors began to blossom through the void like ink spreading through water. Shapes formed. Sounds rippled. A universe building itself around me from scratch. My breath caught in my chest as I realized what I was seeing. It wasn't memory, it wasn't hallucination, it was creation. I floated, weightless, bodiless, within an expanding sphere of origin. Stars igniting like sparks. Worlds spinning into being. Forces twisting and interacting in ways no scientist could ever quantify. And at the center of it, I sensed something familiar, a pulse, a rhythm, matching my own heartbeat. I reached out instinctively, not with my hands, but with something deeper. The moment I did, the universe around me shimmered, rippling outward like a wave reacting to my presence. The void had not been calling to me, it had been mirroring me. This realization hit with the force of a tidal surge. The core wasn't a separate entity. It wasn't an anomaly or a threat. It was a reflection of consciousness, mine, and perhaps of every living being. A bridge between existence and the space beyond it, and it needed me not as a sacrifice, but as a guide. Not obedience, I said. Not submission. It wants connection. It wants us to evolve, not with machines or science alone, but with understanding. His brow furrowed. Understanding of what? That we're not alone, I whispered. Not because of aliens or civilizations, but because the universe itself is alive in a way we never imagined. A slow, dawning realization softened Hale's expression. And you can communicate with it now. It's not communication, I said. It's resonance. A shared frequency. Like breathing in the same rhythm as something infinitely larger. Hale exhaled shakily. So what happens next? I looked out the window again. The stars seemed closer now, like they were leaning in. I have to return, I said finally. The words dropped heavily into the space between us. Hale stared at me. Return. Where? To the threshold, I said. To the place where the core opened. To the point where my consciousness touched the beginning of everything. Jeem, Hale said, voice trembling, if you do that, you may not come back. I smiled softly, sadly. I know. But if I don't go, the station collapses. The chain reaction will spread. And the chance to understand what the void truly is will be lost forever. He shook his head, jaw tightening. There must be another way. There isn't, I whispered, a silence heavier than any gravity settled around us. Hale looked down, his voice cracking. You've already given everything to this mission. And this is the last thing I can give, I said. Not as a scientist. Not as an astronaut. But as someone who was chosen, because I chose to understand. He closed his eyes, accepting the truth he didn't want to face. I placed a hand on his shoulder. You'll finish the research. You'll teach others what we discovered. And someday, someone else will hear the resonance too. I turned to leave, but Hale's voice stopped me. Will we ever see you again? I paused at the doorway, and I answered honestly, I don't know. The station felt different after the resonance, quieter, but not with the stillness of fear. It was a quiet that carried weight, meaning, something almost sacred. Every surface seemed warmer, every corridor somehow alive, as if the void had reached through the fabric of reality and left a fingerprint on everything it touched. I walked slowly toward the observation deck, my steps measured, my mind still reverberating with the vision I had experienced. The universe I'd seen in that white silence. The blooming stars, the rising worlds. It hadn't been an illusion. It was a glimpse into what lay beneath the skin of reality, an origin that was not separate from us, but intertwined. When I arrived, the vast window revealed the familiar expanse of deep space, scattered with distant blue points. I placed my hand against the cold glass and exhaled a long, steady breath. There was no fear now. Only acceptance. Only clarity. Only truth. Behind me, Hale approached, his presence quiet but unmistakable. How are you feeling? He asked, voice soft, cautious. I turned toward him. Better than I should. Worse than I expected. And more alive than I've ever been. He gave a small, tired smile. That sounds like you. We stood side by side, looking into the void that was no longer a stranger. I could feel it, like a gentle warmth behind my thoughts, something watching, waiting, listening. Not demanding. Not controlling. Just present. Hale broke the silence. You said you knew what comes next. I do, I replied. But it's not something I can explain with equations or charts. Then explain it as yourself, he said. As Jean. I closed my eyes. The void isn't empty. It's possibility. It's a place where consciousness and creation overlap. When the core resonated with me, it wasn't choosing me. It was answering me. And I was answering it. I opened my eyes and watched Hale absorb the words. So what does it want? He asked. The core chamber was dim, lit only by the steady pulse of the suspended energy field. It shimmered like a living star caught between breaths. As I stepped onto the platform, the hum deepened, responding to my presence instantly. It knew, it remembered. I took my final breath of the station's filtered air and closed my eyes. This is not an ending, I whispered. Only a return. Light erupted around me, soft at first, then impossibly bright. The platform vanished. The chamber dissolved. And once again, I stood in the white expanse where creation whispered and reality unfolded like a blooming flower. But this time, I did not float. I moved forward, into the stars, into the pulse. Into the echo beyond the universe, a voice, my voice, and yet not mine, spoke within the shining void, welcome home. And I stepped into the place where existence begins, and begins, and begins again, back aboard the station, the core stabilized permanently for the first time. Alarm ceased. Light steadied. The thread evaporated like smoke in sunlight. Hale watched the readings in stunned silence. Everything was calm, everything was alive. He looked toward the empty chamber where I had stood, and he whispered, "Thank you, Jean." And somewhere beyond the fabric of stars,